Good day and welcome. Today, we're exploring electric circuits, specifically two key quantities that help us understand how electricity flows, current and voltage. What exactly is current? Or how do we know how much energy each charge carries through a wire? In this lesson, we'll break it down clearly and show you how to measure current and voltage using the ammeter and the voltmeter. It's important to connect these the right way. Do it wrong, and you could damage your circuit or get the wrong readings. Stay with us until the end. We've got a few questions to test your understanding and help you feel more confident in using these instruments. Quick question: why do you think it's dangerous to connect an ammeter in parallel? Drop your answer in the comments below. And don't forget to like and subscribe so you won't miss our next video. Let's get started. Electric current is the movement or flow of electrons through a circuit, caused by a source of energy like a battery. This charge is carried by tiny negatively charged particles called electrons. These electrons move around and flow through wires and other parts of a circuit. However, for this flow to happen, the circuit needs a source of energy to push the electrons along. A common example of an energy source is a cell or a battery, which provides the energy needed to keep the current moving. So, how do we measure current in a circuit? We use a special instrument called an ammeter. This tool helps us find out how much current is flowing through a particular part of a circuit. The amount of current is measured in amperes, which we write as A. In equations and circuit diagrams, the symbol we use for current is the letter I. Now, it's very important to connect the ammeter correctly, or you could damage it or get incorrect readings. Here's a common mistake people make. Let us say you have a circuit that has a battery and 3 resistors, resistor 1 or R1, resistor 2 or R2 and resistor 3 or R3. Some people will connect the ammeter in parallel with the circuit component they're trying to measure. That's not how it should be done. If you do that, you might blow the ammeter, and trust me, it's not fun replacing it. An ammeter must always be connected in series with the part of the circuit you want to measure. That means the current must flow through the ammeter. For example, if you want to measure the current flowing through resistor R3, you need to insert the ammeter into the circuit at that point. One lead goes to one side of the ammeter, and the other lead to the other side. The current then flows straight through the meter. It doesn't matter whether you place the ammeter before or after R3, the current going into R3 is the same as the current coming out, so either side works. But there's a small catch: to connect an ammeter, you'll need to break the circuit at that point. You disconnect one part of the wire, then attach both open ends to the ammeter so it becomes part of the current's path. This is different from a voltmeter, which you can simply attach across the component without breaking the circuit. That's why using an ammeter can take a bit more effort, but it's worth it for an accurate current reading. Lastly, remember this: an ammeter has a very low resistance. That means it does not block or slow down the current as it flows through. This is exactly what we want. We need the ammeter to measure the current without interfering with it. When connecting an ammeter, it's crucial to match the polarity correctly. The black negative socket should go to the wire leading to the battery's negative terminal, and the red positive socket to the wire leading to the positive terminal. Reversing these can damage the ammeter or cause the needle to swing dangerously, so always double-check your connections before switching on the circuit. Why should ammeters be connected in series? You must always connect an ammeter in series. But why is this so important? The reason is simple: we are trying to measure the current flowing through that part of the circuit, and the only way to do that is to make sure the current actually passes through the ammeter. That's why ammeters are specially designed to have very low resistance, sometimes as low as a milliohm. If an ammeter had a high resistance, it would interfere with the current flow, changing how much current flows through that part of the circuit. This would make your measurement inaccurate, and it would defeat the whole purpose of using the ammeter. So, when you insert the ammeter into a circuit, it's designed to act almost as if it isn't even there, just quietly measuring without disturbing anything. Let us say you have a circuit that has a battery and 3 resistors, resistor 1 or R1, resistor 2 or R2 and resistor 3 or R3. Current or electrons will flow from the negative terminal and pass through all the resistors R1, R2 and R3 towards the positive terminal. Now, here's why you must not connect an ammeter in parallel. Let's say you connect an ammeter across a resistor, like R3. One lead goes on one side, and the other lead goes on the other side of the resistor, R3. As the current approaches that point in the circuit, it reaches a fork in the road. The current now has 2 paths to choose from. It can go through the resistor R3 or go through the ammeter. Because the ammeter has almost no resistance, the current will naturally take the easier path and flow entirely through the ammeter, completely bypassing R3. Now all the current is rushing through the ammeter's tiny resistance, and this can burn out the ammeter. That's why most ammeters include a fuse to protect the device when this mistake is made. So again, never make this mistake. An ammeter should never be connected in parallel. Always connect it in series, where the current flows directly through it. What is voltage or potential difference, and what does it tell us? Voltage, also known as potential difference, is the difference in electrical potential energy per charge between 2 points in an electric circuit. It tells us how much energy each charge loses or gains as it moves through the circuit. When charges flow through a component like a resistor, they lose energy, and that energy is transferred to the resistor in the form of heat, light, or sound. On the other hand, when charges pass through a cell or battery, they gain energy. This happens because the battery uses its chemical energy to give electrical energy to the charges, pushing them through the circuit. Voltage is like the push that moves the charges through the circuit, and it tells us how much energy each charge is getting or giving away. Voltage is all about how much energy the charges are using or receiving at different parts of the circuit. It is measured between 2 points in the circuit. Voltage, or potential difference, is measured by means of an instrument that is called a voltmeter. The unit in which the magnitude of voltage or potential difference is measured is called a volt, V. Since a voltmeter is not used to measure current, it does not need the entire current to flow through the instrument. Because of this, the voltmeter is not connected like an ammeter in series. Instead, it is connected differently in the circuit. So, how do you use a voltmeter? You take the voltmeter and connect its leads to either side of the circuit element you want to measure. For example, if you want to know the voltage across R3, you would connect the voltmeter's leads across it, one on each side. If you want to know the voltage across R1, you do the same thing, hook up the voltmeter in parallel with R1. This part is very important. Voltmeters are always hooked up in parallel with the circuit element being measured. If you want to check whether your battery is functioning correctly, you can connect the voltmeter across the positive and negative terminals of the battery. This will give you a reading of the voltage across the battery and show you whether it is still supplying the correct amount of energy to the circuit. When a voltmeter is connected in parallel with a cell or battery, we say that it is measuring the battery's capacity to deliver energy. This tells us how much electrical potential the battery can provide to push charges through the circuit. On the other hand, if a voltmeter is connected in parallel with a resistor or a light bulb, we say it is measuring the capacity of the cell or battery to cause current to flow through that component. It tells us how much energy is being used by the resistor or light bulb. It's important to remember that a voltmeter is built with a very high resistance, which means it offers a lot of resistance to the flow of electrical current. This is done on purpose, so that the voltmeter does not disturb the flow of current in the circuit while it is taking a reading. A voltmeter has a black negative socket and red positive socket. To ensure accurate readings and protect the device, the black socket should connect to the wire leading to the battery's negative terminal, and the red socket to the wire leading to the positive terminal. Correct polarity is important when using a voltmeter. Now, why do we connect voltmeters in parallel? This is because we want to measure the voltage across a circuit component, and voltage is defined as the difference in electric potential between 2 points. Voltage is not measured at a single point. It doesn't make sense to ask, what's the voltage at this point? Voltage is always between 2 points. You can ask, what's the voltage between point A and point B? That's valid. To measure this, you hook up the voltmeter across those 2 points in parallel with the element. As we have seen, voltmeters are made with very high resistance, sometimes hundreds of thousands or even millions of ohms. Why? Because you don't want the voltmeter to disturb the current flow in the circuit. If the voltmeter had low resistance, current would flow through it instead of through the resistor you're trying to measure, which would change your result. So, even though a tiny amount of current does flow through the voltmeter when it is connected in parallel, this current is extremely small because the voltmeter is designed with a very high resistance. This high resistance makes it very difficult for current to pass through the voltmeter, which is exactly what we want. As a result, almost all the current continues to flow through the component we are measuring, for example, through the light bulb instead of being diverted into the voltmeter. This means that the circuit is not disturbed, and the current flowing through the light bulb remains the same as it would be without the voltmeter. Because of this, the voltmeter gives us an accurate measurement of the voltage across the light bulb, without changing the way the circuit works. This is very important because we want to measure what is really happening in the circuit, not something that has been changed by the measuring instrument itself. What if you connect a voltmeter in series? You could ask, what if I connect a voltmeter in series instead of in parallel? Remember, voltmeters have huge resistance. So, if you placed one in series with the light bulb, very little or no current would flow through that part of the circuit. The circuit would essentially be broken. You might not damage the voltmeter, it's not as delicate as an ammeter, but you'd still get no meaningful reading. The voltmeter wasn't designed to be used that way. A multimeter is an electronic tool used to measure voltage, current, and resistance in a circuit. It can act as a voltmeter, ammeter, or ohmmeter depending on how you set the dial. When using a multimeter, it's important to be careful with the settings, as using the wrong one can easily damage the device. In one instance, a multimeter was used throughout the day on the ammeter setting to measure current without any issues. Later, a voltage measurement was attempted, and the device was connected in parallel as is appropriate for voltage readings. However, the dial had not been switched from amps to the volts, and as a result, an ammeter was inadvertently connected in parallel. The internal fuse of the multimeter was blown as a consequence, and repairing it proved to be inconvenient. It is therefore strongly advised that the dial on a multimeter be checked carefully before any connection is made. Ensuring that the correct mode, volts or amps, is selected can prevent potential damage to the device. We have come to the end for today. Today, we discussed the meaning of current and voltage and how they are measured. Before we go, please attempt the following questions before the answers pop up. You can pause the video as you go. This is an important section that consolidates what you have learned. In the next video, we will be looking at cells connected in series and also in parallel. Be sure to check out the link for this in the description for more videos. Also, please do not forget to like and subscribe so that you do not miss our weekly uploads. Otherwise, thank you for watching and keep well.